So today our guest speaker is my friend Chris. Made it up here from the South Bay. Really appreciate it.
Happy to be here.
We're going to talk a little bit more about data. We've done a lot of statistics recently and kind of gone down the rabbit hole with some stats. But we're not going to talk about stats. We're going to talk a little bit about data and what you do with it. And then he's also going to talk about what he does for fun that is also engineering and really cool. And then there's some cool demos.
Yeah, absolutely.
Thank you for being here.
Thank you very much. All right. Hello, everyone. So I'm sorry about the date here. We've all gone back in time for the next hour, 8 days. But as was mentioned, I'm going to talk about genes, virtual worlds, and how to control devices with your mind. So first, I wanted to say a little bit about me. Here's my character sheet. As you can see, I am a principal software engineer at DNAnexus. This means that I lead the front-end team doing web development work, making sure that all the researchers that we provide services for can access their data. When I went to college, I majored in French Lit and computer science. I'm sure you can see the crossover there. No. Minored in psychology. And this allowed me to go through a variety of paths in my life, including being a lab assistant in the psychology lab, a language instructor, which means I actually taught language instructors how to use technology in teaching foreign languages to their students. That was actually great because I got to use my French and computer science and psychology all at once, the one shining time in my life where I got to do that. I worked for an online textbook developer who in the year of 2011 had the radical notion that the internet was a fad and print textbooks were the way to go. I think we all can see how that one's going out. And I also narrowly avoided working on interrogation devices, actually as a direct result of the final project that I'm going to talk about. I'm also strong versus fire type and weak versus water type. I do actually do fire eating and I do scuba diving, just not at the same time. But I'm telling you all this to try and convey a very important lesson. And that lesson is not, I'm awesome, look at how awesome I am. The lesson is, this is a pretty eclectic background here, and I still found a bunch of stuff to do. So, going to college, I would say study what you want. Don't feel pressured just to go into computer science or EE or whatever because it's the thing that makes money. You can go get an art degree, you can study psychology, you can study whatever you want, there will be stuff out there. I promise you. Okay, so with that, let's talk about genes. So as I said, I work for DNAnexus, which I describe, this is not our official tagline, I describe it as a cloud-based platform for genetic analysis and machine learning, which I think may be approaching the maximum density for buzzwords. If anyone else has any other buzzwords that they can cram in here, let me know. I'm pretty sure if we stuff a few more in there, like we get a black hole or something. But what does DNAnexus actually do? So we provide space for researchers who are doing genetic analysis to take the sequencing results from taking a bunch of biological samples and running them through a machine and do analysis on them. This analysis could be things like prenatal analysis to see if a couple that's expecting is going to have a child that has any sort of genetic disease. This could be cancer analysis, trying to find the cause of someone's cancer. This could be analysis for crop genomes, trying to engineer crops that are more drought resistant or pesticide resistant, or pest resistant, sorry. Could be anything. Why do I like it though? So, this is an obligatory slide for any genetics talk. If you go to a genetics talk, especially at the intro level, I think we all have to sign a contract that says that we will display this slide from the NIH. This is taking Moore's Law. And you all know Moore's Law? Yes? No? No? Okay. Does anyone know Moore's Law? What is Moore's Law?
Not really a law at all, but just that computer processing power, or sorry, the amount of resistors you can fit in an area will double every 18 months.
Yeah, exactly. It's been phrased in a lot of different ways, some with varying degrees of accuracy. The way it's most commonly phrased is that processing power will double every 18 months, which Your answer is actually more correct than that, so thank you for actually doing that. But this means that computers are a very fast-paced field, as you well know. Here we have a logarithmic graph. So every tick here is a 10-fold increase over the previous tick. So you can see Moore's law is a line here, where if it were to be plotted on a linear graph, it would look something more like that. This is the cost of sequencing of a genome. And you can see that versus something that is linear on a logarithmic graph, it is in turn logarithmic. So that means that the field that I work in is at the intersection of two very, very fast-paced fields. I love it because there's always something new to learn. There is always something new coming out. And it is constantly just a stream of really interesting stuff that you get to research, or I get to research, and deal with and try and put into practice. One other reason I like it a lot is because it's got a high feel-good factor. So 2 years ago, I was managing 2 projects. One of them was a joint project with St. Jude Children's Hospital. It was literally helping cure children with cancer. I mean, it doesn't get better than that, right? Maybe children and puppies with cancer, I don't know. But it was fantastic. We were working together, we were trying to make all these data sets available to researchers so that they could more rapidly come up with cures for children who were at risk of literally dying. And this was my jam. Like, I loved this. That said, not every project is quite as much of a feel-good project as this. The other project that I was managing at the time was one called Mosaic, which deals with microbiome research. I don't know if you've heard the term microbiome being tossed around. It's a hot topic in a lot of biological research, but because of my position in the company, I'm not sure how much that filters out to the rest of the world. Microbiome is basically your gut. So all the bacteria that help you digest foods, that help keep you healthy, help fight off any parasites or anything that you might ingest accidentally. Unfortunately, this meant that if we were to share samples for microbiome research, we were seriously talking about mailing human excrement around the world, which was a little bit weird, especially in conjunction with saving children with cancer. It's like, children with cancer, awesome. Mailing fecal matter. I'm pretty sure that's a practical joke. But it all came out to a good end, so to speak. This project has been making a lot of good advances in microbiome research, so I do feel good about that. So, these are the great things about what I do. Some of the not so great things, biology is messy. And I don't mean like human fecal matter messy. I mean the data is messy. So we were talking, you mentioned statistics at the beginning. There is an in-joke in biological fields about the biologist's line, which is this thing. So this is a line of correlation. And when you have a lot of very messy data, samples don't always behave exactly the way you want. They don't always give you clean results the same way that electronics often do. Not always, but often do. So you get these clouds of points which don't seem like they're related. So you have an outlier over here, you have this stuff over here. I don't even know what's going on with this guy up here. And yet, every biologist feels compelled to draw a line through the middle of the graph and being like, yep, that's the trend. Absolutely. This is where that goes. And you look at it and you're like, really? How did you get that? I don't know. Dealing with messy data requires a lot of wiggle room in your algorithms. And it means that we have to develop a lot of statistical methods that are very tolerant of noise and outliers and just things that don't always look clean. And so that is a huge challenge in biology. Not just genetics, basically all of biology. And sometimes it can get pretty maddening. So, all that said, what do I actually do? So I work on a front-end product that helps researchers analyze their data. So this is a screenshot, or a mock-up rather, of sort of what we are working on right now. So we have a bunch of samples that we've taken from a large number of people, and this is a tool to look at population-wide trends. So researchers could use this to look for common factors that cause diseases. They could look for good targets for medications to address. They could look for basically anything they want to and do it across hundreds or thousands of genomes at the same time, which is something that no one has done on that scale before. And that's kind of exciting to me. Like, that's new. That's something that no one's done, and I get to work on it. So, yay. All right, let's move on to something a little more fun. Virtual reality. So, I love VR. You might get that sense by the end of this. I'm old enough to remember the promise of the first stage of VR. So virtual reality has been around for decades. Back in the 90s, it was a big, hot thing. This is what we were promised. We were promised these big worlds that were fully immersive, and you couldn't tell them from reality. You all know what this is from, right? Awesome. Thank you. Yes, I'm not that old yet. So this is what we were promised. We were promised all these things. And I think we're well on track to seeing the internet look exactly like this in 2 years. It sounds about right. Cool. And it flopped terribly. This is what the reality was compared to what we had there. This was the one and only televised VR game. They had a game show called Dactyl Nightmare. It was legendarily atrocious. So understandably, when you had graphics that looked like this, and people and equipment who looked like this, being your showcase for VR, it didn't really take off. So it kind of went underground for a little while, people started working on it a little bit more, and finally, we're at the second age of VR that's just taking off now, and its primary focus seems to be, as far as I can tell, making headsets look good. Put them on attractive people that look like they're having fun, and you will also want to put on a headset. It actually kind of works. Like, I do feel like I want to put on a headset and see what they're seeing, especially this guy. I don't know what he's doing, but that looks really good, whatever it is. Seriously though, the capabilities of VR now are so much better than they were back in the 90s. We actually have graphics that are reasonable, that are, if not realistic, at least realistic enough that you can tell what's going on. Motion tracking is a very hard problem that we've finally been able to solve. We finally have companies that are invested in making the experiences engaging, and most of all, the price points are finally at a level where they're available to the average consumer. That said, there are still a couple of holdovers from the old world. So you remember this thing? This is in my office right now. I actually use it. It looks pretty much the same. I got it. I'm just glad that no one's actually published a video of me using that thing yet. But one of the great things that I like about VR, which should sound very familiar, is that it is Terra Incognita. It is completely unknown as a media form, and that means that we get to explore new things. We're just now entering the phase where people are writing real software and real games and real experiences. The last few years have basically been tech demos. It's been everyone collectively figuring out, well, does this work? What happens if you reach out to grab this? Do you have to actually hold your hand clenched? Do you have to just like hit a button on the controller? Like, what happens if we, have a player move this way? No one has a script for how to do this. No one has guidelines. Well, okay, that's not actually true. We do have some guidelines that were figured out very early on, and they are a litany of ways to not make your user throw up. Those are very easy to discover and very important to adhere to. But beyond that, we have basically no guidance, and so anything that you want to do is valid. Like, you can make an experience however you want, and no one is there to tell you, oh yeah, that's not going to work. That's totally the wrong way to do that. No, heck with it. Do what you want. So, that said, I did what I wanted with data. So this is a project that this is the starter project that I did for my company. DNAnexus is very good in that it gives us time to work on our own personal projects, sort of as a 10 or 5% time project. As long as it's related vaguely to what we do, we can do whatever the heck we want. So I took a Manhattan plot, which is what this is. Here we have chromosomal location and basically significance of any individual piece of data here. This is great. It can tell you, okay, yes, you've got some significant data over here. That's great. What is it? We don't know. It's just stuff there. Go find out somewhere else, what it actually is. And if you're doing a genome-wide association study with hundreds or thousands of individuals participating, so these points of data could come from any one of those individuals, you have no idea who it belongs to, like if this piece of data and this piece of data are from the same person, or how common it is in that population. So there's a lot of information that's missing here. So what I and a pair of scientists at DNAnexus did were to engineer a virtual reality version of this graph, where the user stands at the center. Wow, this is really bad resolution on this monitor. There's nothing like a high-resolution monitor to tell you how crummy your video quality is. All right, so the user stands in the middle and is surrounded by their data. And you can reach out and manipulate some of the data, you can select a point of data, and you can see not only where it's located on the genome, what the significance is, gauged by height, but you can also see how common or rare it is. So depending on your research case, you may be looking for something that is more common. You want something that affects as much of the population as possible. Or you might want something that's really rare. You want something that may explain a particular outlier that you've seen, or maybe you want just another direction to take your research in. And that you can gauge by the distance from the user at the center. So closer is more common, further out is rare. And it really adds a new, if you pardon the pun, it really adds a new dimension to the data. We ran this by a bunch of researchers at one of our user group meetings, and the reactions were varied. A lot of people just stood there with their mouths wide open and were like, wow, I've never seen my data this way before. And these were people who generally didn't have a lot of experience in VR. And so like they would kind of walk over and try and reach out and touch their data, and invariably get their head yanked back by the cord that attached the headset to the computer, which never gets old, by the way. And then we had a lot of people who were skeptics, who were like, well, this is great and all, but what does it do practically? And these are actually my favorite people, because when you find someone who's skeptical about what you've done, and you ask them to explain why they're skeptical, that gets you in a dialogue, and it gets you a lot of ideas on how to improve your thing. And so that's exactly what happened here. All these people who are like, well, I don't get it. Like, it would be more useful if you did this or this or this. Oh, and you could go out and have the interaction be something more like this. Oh, and I would love to see this information. I got a whole bunch of ideas on future projects from talking to these people. It was great. So even though the graphics may look a little more like the first stage of VR than some of the new stuff, for about a year's worth of work between 3 people, 2 hours a week, I'm pretty proud of this. My next project is to take this, which is a Genome Browser, and try and put it into VR. So my theory is that VR is a great space to show huge amounts of data. With a computer screen, you have a very small space. It's not great for navigating what we refer to collectively as big data, such as this, for example, which is 1/6,600,000th of the human genome. This is already a lot of data right here. Trying to stuff 6.5 million times this into a computer screen is not going to work. With an entire world at your disposal in 3 dimensions and all around you, I think there's some stuff that can happen there. It may not quite be taking us back to here, but hopefully hopefully we can get there before long, or at least take a couple of steps there. All right, so that's what I do for work. Now for some fun. Mind-controlled Nerf guns. So whenever I say mind-controlled Nerf guns, people usually have one reaction, which is something like that. Why? Why would you want to build a mind-controlled Nerf gun? Frankly, I got nothing. I'm sorry. I have no idea why I did it myself. I had a Nerf gun. I had this EEG headset lying around. I was like, we'll cram them together and see what happens. It was a great experience for exploring physical electronics, though. And as someone who mainly deals with software, actually holding a thing and manipulating it and being able to make it work is great. So let's start with the hardware here. There is a company down in San Jose called NeuroSky that sells hardware for reading basic brainwaves. You've got your alpha brainwaves, beta, theta, gamma, delta, basically everything that you would expect. It's cheap. Depending on the unit you get, it's between $40 to, I think, $80 or so. And they have a rough guide for hacking it to figure out how to make it work with your electronics. So I went online, followed their documentation, and was like, okay, let's hook this up to an Arduino. This company also makes other very highly relevant hardware. Brainwave cat ears, very important product. I actually have some, we can try them out later. But it's the same sensor. And also, if any of you remember like the Star Wars Jedi mind thing, where you have this little jet of air that you have to guide through an obstacle course that's controlled by your mind, exact same sensor. It's the same company who made that. So you can hack that if you want to. Like you already have a brainwave sensor if you have that. So, the Nerf gun. I was going to bring the Nerf gun and crack it open and show you the modifications that I made until I picked it up and looked back at the documentation that I made and realized it has 34 screws just to get in there. And I'm sorry, I like you all, you're all great. You're not 34 screws great. I'm not opening that thing just to show the inside. So here are some pictures. So fortunately, it already had a motor that would control the firing. It was battery powered. All I had to do was just kind of splice in some wires and hook them up to an Arduino and basically throw in a couple of relays, which you can see right here, to basically simulate pulling the trigger. And that way I could programmatically say, okay, Arduino, fire. Okay, Arduino, stop firing. You can see the two jacks that I added here. One is actually to go to the Arduino and is connected to the relays. The other one is actually for power, because I found it easier to just hook it up to an external power source than to plug in, what was it, something like 6 D cells, which was really, really heavy and also kind of a pain to work with. I love this one. This is my really cheap helping hands. I think I got this free from a conference from Yahoo, back when Yahoo was actually relevant. I'm sorry if anyone has relatives working for Yahoo. That was meant in jest. And then I hooked all that up to an Arduino. So here you can see a picture of the Arduino and the Bluetooth board. The Bluetooth was for connecting to the headset. Yes?
What is a relay and what does it do?
Good question. Okay. So a relay, so a relay is a box here, and you can think of it basically as an electronically controlled switch. It actually has a physical switch that goes back and forth between two poles depending on the electrical charge of either of the poles. So what I really wanted to do was use a transistor, which is faster, cheaper, smaller, takes less power. I am rubbish at transistors. There are, it turns out, about 50 different types of transistors out there, and I can never pick the right one. So rather than going through like 50 different types of transistors, I was like, a relay? Relay is not that much more expensive. It's more reliable. It's a little clunkier, yeah, but it's also kind of nice having a physical switch with a piece of metal that goes up and down depending on whether you want it on or off. Good, okay, cool. Yeah, so Bluetooth board, Arduino, Nerf Gun, Mind headset. Here's the pinout for doing exactly what I did. And this is when I discovered a very important lesson. So, see this red wire and this black wire? The one that says voltage and ground? You know what happens if you flip them? Something about like that. So, that was a 2-week setback and $30 while I waited for a new Bluetooth board to arrive in the mail after literally seeing a puff of smoke come out of my old one. And that's when I learned that for any electronics project with anything that I paid money for, I probably want to spend an extra 3 cents for a diode, which I can put between the voltage or the ground, and it will allow electricity to flow one way but not the other. So if I were to reverse the polarity, I guess, one of those sci-fi cliches, it won't destroy my board. So, good lesson to learn in electronics. Anyway, I took this thing to Baker Fair. That's me, looking very happy. I showed it off. Everyone loved it. Everyone who tried it found that the same thing that I first discovered when I made this, which is that you really need to think about what happens after you achieve your goal. Case in point, when I first got this thing working and the first time that it fired, I was like, yes, it's firing! I am amazing! Wait, how do I stop it from firing? Because I was just so excited that my brainwaves were spiking, and the gun just kept firing and firing and firing, and it was impossible to just calm down because of my success and be like, okay, zen, stop firing. No, that wasn't happening. So always think about what's next. Also important in robotics, when you have robots that are on wheels or anything that is self-motivated and self-navigating, because if you only have a power cutoff on the robot itself and it is taking off down the hallway, you're in for a good chase. Anyway, so yeah, I took that to Maker Faire. The headset was great. It went through about 400 little kids' hands, and unfortunately, any hardware that passes through the hands of 400 little kids is doomed to failure, which is why I don't have the entire apparatus here. Because RIP, brainwave device. All right. So, lessons. I thought a while about what lessons I wanted to have you take away from all this, but as you might recall from slide number 2, I'm a lit major. And as a literature major, I believe very firmly in finding your own meaning in things. So, I'm not going to tell you any lessons. Hopefully something that I've said here resonates with you. Each of you is free to take away whatever you want from this talk, be it a technical thing, be it a philosophical thing, be it both. I hope it's both. But I wanted to open it up for Q&A if you have any questions. And thank you. Yes?
How did you get into VR? How did you know that you wanted to use that project for the game?
It's a really good question. Like I said, I was around for kind of the first iteration of VR, and I think what really captured me was the promise, even if the actual implementation at that time fell flat. Just the idea of being in a virtual world, of being able to be completely immersed and interact with anything you can imagine really captured me. And then years and years later, when it came around again with the Oculus Kickstarter and the Rift first getting going, I was just starting work at DNAnexus, and I kind of made the connection and was like, well, everyone's going to be looking for games and experiences, and that's where most of the market is going to be. And indeed, that's where most of the market is. No one's looking at data visualization in VR, and I think that has a lot of potential, and that was kind of the psychology minor in me speaking, being like, well, you know, we have a lot of principles for how to do data visualization in 2 dimensions. 3-dimensional data visualization is by and large a joke because it's all 3-dimensional data visualization printed on a 2-dimensional screen. which means you fundamentally lose an entire axis worth of information, even if it's poorly represented in 2 dimensions. So having something that's actually 3-dimensional, I think, has a lot of potential, and I'm really excited to explore that. And to this day, it's happening that day. Yeah.
Did you level up recently?
You know, have I leveled up recently? I'm trying to think of one grand experience, or the last time I heard the level up music.
Your slide had
Yeah.
141 hit point, experience points out of 40,000, so some means you leveled up recently.
I could have been spending a lot of time in the tavern is the problem.
Okay.
Yeah, actually I did level up recently. At work, I'm finally getting to lead my own team, and it's becoming a multinational team. So that is definitely a lot of skills that are getting points dumped into them.
Okay.
Yeah, lots of fun. Yes.
Do you have instructions for how to make the Nerf gun?
I do. Thank you. I will, I guess, put them up on the board, as well as some contact information in case anyone wants to get a hold of me. I will give you some forewarning. The website that contains the instructions is very old, so you can go to the website and laugh at the outdated CSS that's up there. But the instructions should, by and large, be sound. I guess the other caveat is that because this project is a little bit old, the hardware from Neurosky may have gone through a couple more iterations, and I haven't done any checking to make sure that it's still relevant or that nothing has changed. So. But yeah, absolutely.
Why did it cost $100 million to do the sequence one genome in 2001?
Why did it cost $100 million to sequence one genome? That's because a lot of that was being put into research on how to do it. It's something that we hadn't done before. And so when you have something that has been commoditized, you put a lot of money into developing a process to make the equipment for doing that very swiftly, very easily, and very cheaply. This was all people who were basically like putting together machines, soldering circuit boards together from scratch, and also going down a lot of pathways that ended up being fruitless as to how to do this in the first place. If you look at sequencing technology now, it's actually surprisingly hacky. We basically, in order to read bases off of a genome, we go through a process called PCR, which basically amplifies the genetic material, and we attach primers to the end of each of these strands of DNA. And those primers have a particular photofluorescent material on them. So if you shine a black light on them, they'll glow green or red or blue or yellow. And so for each of the different bases, A, G, C, and T, they're a different color. Which means what we're doing is basically putting in some DNA, taking a picture of it, seeing how it fluoresces, and using vision detection to say, oh, that's an A. Then we pop that base off, do the whole thing over, oh, that's a C, and just do it over and over again. So we're really just taking pictures of DNA and doing image analysis, and that's how we're sequencing DNA now. Most commonly. There are some other methods that are coming out, but that's the most common version. So hitting upon that took a lot of research, a lot of personnel, and a lot of time. And yeah, correspondingly a lot of money. All right.
How much documentation do you take on your personal projects?
I would say it depends on how far along the personal projects are. So, very good question. So the Nerf Gun has actually a lot of documentation. For projects that don't get quite as finished, there's usually a decent amount of documentation, but it's all kind of shorthand notes, stuff to help me remember where I was or what I did, or notes to myself of what to do or what not to do, to-do lists. I wouldn't say a lot of it is useful to other people. And then, of course, there are the projects that sort of get started, and I spend like maybe 4 or 5 hours on them, and I scratch that itch, and I'm like, okay, that was fun, but I don't think I'm going to do this anymore. And those usually have no documentation. So.
Can you talk about what you brought?
Absolutely. So, as promised, if anyone wants to try them on, we have the cat ears. They're actually a lot of
surprisingly
fun. They are. They
It's
are
a
a
trip.
lot of fun. We also have a VR headset. If anyone has not had the opportunity to try virtual reality before, now's your chance. And I can set it up over there where there's a large empty space. And I don't know, do you want them to build a list of names?
Yeah, if you want to try it, if you're a morning student, let's go ahead and give you some priorities since I know you probably need to take off. But yeah, we can try it. I mentioned Beat Saber earlier.
Okay.
The good trial game that's on there.
All right.
So if you're not sure what that is, you can YouTube it real quick so you actually know how to play. Unlike Palo Alto, which is like, what am I doing? And had no clue. Still had fun. They still had fun, but they had no clue. So yeah, that's
Okay.
thank you.
I'll get that set up.